Hello and welcome to this demo where I'm going to show you an example of building a modern data pipeline utilizing some of the features around ZeroETL and generative AI. So firstly, what is ZeroETL? This is a set of integrations that AWS has been working on that can help speed up the delivery of data from operational systems into analytical planes. Now it supports a variety of different sources, and I've put some links to some resources here that can show you the different sources and targets supported. But it's a way that you can move away from having to build your own ETL jobs that move data around that can become quite brittle and complex to manage at scale, and instead just rely on this ZeroETL replication to take your data from your operational database into an analytical plane. This all brings you increased agility and increased speed to insights because as data is now inserted, updated, or deleted in the source system, you can have that data replicated in real time in your analytical target. Generative AI is influencing how we build data pipelines as well. And there's a variety of different places this can provide value. There's a few that I'm going to talk about in this demo, which is principally around the use of generative SQL within Amazon Q. So Amazon Q Generative SQL is baked into the Redshift Query Editor v2 and also a part of a SageMaker Unified Studio domain. It can look at your database schema and help you take natural language questions and convert that into relevant SQL queries. Next, we'll touch on the Amazon Q data integration in AWS Glue. So this allows you to chat with Q around your job development and recommended practices. It allows you to ask for full code generation. So you're again describing your intended job in natural language and having that converted into code for you. And if you're running into issues, it can help you look at the logs of your job and help you detect the root cause error and suggest any resolutions. The other thing we'll look at is once we've built some of this pipeline, so once we've ingested some data with ZeroETL and built our transformation job, we might ultimately want to publish this data via our business catalog. And so we'll use Amazon SageMaker catalog to do this. And again, we'll use generative AI here to come up with recommendations for our business metadata. And we'll see that in action later. Finally, I'm going to quickly touch on Amazon Q in QuickSight. So you'll have seen previously a lot of BI tools had natural language integration where you could ask questions of your data and it would surface recommended visualizations. This is the next generation of that sort of capability. And you can now use generative BI to ask for complete visuals to be authored for you, to create summaries of data. So it'll look at the visuals and the data that you have available and come up with these succinct exact summaries for you. You can ask free text questions of your data just as you would before, and Q and QuickSight can generate visuals for you to help you answer these questions. And finally, you can generate data stories. So again, a few more resources on that if you want to find out more. So in this demo, we're going to be looking at this architecture. This is a somewhat cut down view, but essentially we're going to have an Aurora MySQL serverless source. So this is acting as our database, our operational database source. You can imagine it might be a database sat behind a web server or similar. We're then going to establish a ZeroETL integration to send this data into our Redshift environment. This means that we'll have data replicated from the operational source and put into the Redshift environment to allow our large-scale OLAP analytics to run. We're also going to turn on history mode with this part of the ZeroETL integration, and that allows you to capture the current status of your record, so whether it's active or not in the source, and when these changes happened, so when the source was written and when the update was happened. This assists you in building your slowly changing dimensions and dealing with changes in your analytical target. I'll then quickly show you how you can connect this data to QuickSight, where you can then start using some of those Q and QuickSight generative BI capabilities. And I'll also show you how you can publish the data that you had in your Redshift environment via the SageMaker catalog, and again use some of the generative AI capabilities to build up that metadata. Now there's some sample code on GitHub that can help you get started with some of this, mainly deploying the VPC resources required and the Redshift cluster with the relevant parameters. So if you want to check that out, follow the links here. So after deploying that sample code, one of the things I'm going to get is this source RDS MySQL cluster, which is going to act as my operational database where I'm established a source, and I'm going to have my Redshift target, and this is a serverless warehouse that I'm using, which is where we're going to send our operational data. So the first thing I can do is establish the ZeroETL integration. So I come here and I'm going to create the integration. I'm going to select my RDS database. You have the option to apply some filtering here so you don't have to bring through all tables. And now I'm going to select my target. Select next, and now create the ZeroETL integration. So once our ZeroETL integration has finished creating, you can review any filters you've applied and head over to your Redshift target namespace where we can again view the ZeroETL. And there's a few things we need to configure here. So firstly, we need to create the target database. I'm just going to call this one demo. And this is where we will have our data replicated to. So now that we have our ZeroETL integration set up, we can actually start to populate the source data. So again, in reality, this will be coming from an operational system. We're just going to load some sample data. So to upload the data, I'm going to come into data group here, and I've connected this to my source. So my source database. And I'm just going to upload some sample data from the NHS Business Authority. So you can see here that we've got a pretty standard data set. Like I say, in reality, this would be being driven by an operational system. We're just doing it manually just to show you this in action. One thing that we do need to do is make sure that we have a primary key column. So I'm just going to create this ID column here so that we can use this as the primary key. This is important in establishing the ZeroETL. So once that data is loaded, we can see now that we have this table in our operational database. So in our MySQL Aurora cluster, we have our data ready. And as soon as this is written into that source, those transaction logs are going to be read, and the ZeroETL is going to replicate these inserts across into our Redshift target. So if we head back to Redshift Query Editor now, I've connected to my Redshift serverless workgroup. So this is the target for our ZeroETL. You'll have seen how we've had a demo sort of schema created for us. This was the naming that we set up during the Redshift ZeroETL integration. And you can see now that we also have this table has been replicated across. And a quick select from that shows that this is our source table and it's just been created in real time. And we have all the data available to us. We can now start performing analytics on this data, and as any updates are coming in on the operational system, they're going to be replicated across into this target Redshift environment and allow us to pick up on those updates in near real time. So one thing I've done here is I've just gone into manage history mode and I've turned it on for all existing and future tables. So what this means now is that we're going to have metadata added to our table, which tells us around whether the record is active in the source system or not. So i.e. has it been deleted on the source system? And then also gives us some timestamp metadata around this. So now that our history mode is turned on and our table has been resynced, we can head back to the query editor and we can issue the same query again, and we'll see the updates that made to the table. So you can see now that we again have the same table data replicated across, but now we have the addition of these additional records. This tells me the record is active field, tells me whether that record is the one that is active in the source. It tells me when that record was created and when it was deleted. So let's see this in action by heading back to data group and making some changes. So again, in reality, this would be changes coming from your operational systems, but we're just going to do this ad hoc. So I've started by deleting from the table where the ID was 1. So that record should now have disappeared. So now I'm just going to run this query on Redshift just to show you what happens now that the ID has been deleted on the source. So you can see here we still have the same reference to all of the data. If I scroll across to our history metadata, you'll see now that the record is active field has gone to false, and we have the timestamps for when this data deletion occurred. So back in data group, let's do something similar to say let's update a field this time. So again, you might have had one of these contracts may have changed value, so we're going to change the value band. So it's an update to an existing field. We'll run that, and again head back to Redshift to see the results. And now again, we see now that we have 2 records in the table, and our field data here tells us that one of them, this one is the one that is active in the source. And we can see if I scroll to the value band field, this is the one with the correct value. And again, we get our create and end delete times for these events. So it can really help you in building up changes into your analytical environment and building slowly changing dimensions. So now that we have our data in the analytical plane, one of the things that we wanted to show you is the generative AI capabilities to help you in building your pipelines. So what I'm going to do here is I've created a workbook and I'm going to start interacting with the Amazon Q Generative SQL. This allows me to open this chat box and start submitting natural language questions to my data. Q is going to use metadata around your database and schema information to develop a target query. Once the query has been generated, I can add this to my notebook, I can provide feedback, and I can run the SQL query that was generated. You'll see that it has been able to pick out that it needs to add a filter for the is record active is true, and I now have a SQL statement that helps me answer my question. So that was a fairly basic question, but if we increase the level of complexity, we'll ask for something similar, but this time generating percentages. So we know this is probably going to need a CTE or something similar to calculate this. And again, we can see that we get a SQL statement generated that I can run, and it gives me the answer, but now in percentage form. So that's how you can get started with quickly developing SQL queries, helping you to boost your productivity. These still need to be checked, these records, for accuracy. So the next thing I want to show you, I've come into SageMaker Unified Studio, and I've got a pre-existing project set up within this domain. Now, SageMaker Unified Studio is out of scope for this demo, but I do have other demos on it if you want to check those out. So within my project here, I've added my ZeroETL Redshift warehouse as a compute environment, so that now if I wanted to, I could query it from within this experience. So I get the same table, the same Redshift warehouse environment, and the same history record metadata. You can see that in my Lakehouse environment, I've got some sample data. So one thing just to quickly show you the capabilities of Q in the data integration is we're going to change this date field here to actually be a date rather than a string. So I'm just going to capture the name of this table and show you the data it contains. So again, fairly standard table that was in our lakehouse. We just want to change this field to be a date value rather than a string. So if I go across to my visual ETL flow, I can create a visual flow, and I can simply drag and drop these nodes together to do the transform, or I can ask for it in natural language. So you can see I can submit my transformation in natural language. I'm just doing a very simple one here. Submit that and it will be generated for me. Once the job has been generated, I can just configure these nodes to point to the right table. You'll see that I get data previews along the way, telling me the status of my data. I can change the store open date, give a target name for the new name, for the new column name, and then change the target type to now correctly be a date. And then I can write this out into my Lakehouse environment into a new table. So that was just to quickly show you how you can use this capability to help you generate your integration jobs. For now, the next thing I want to show you is how you could, for example, take that data that we loaded into Redshift via the ZeroETL integration and publish it via the catalog. So at the minute, we've got this table here that's potentially providing valuable insights to our business. Imagine that we've done a bit more transformation on this, really curated an asset, and then we want to publish that. The next thing you might want to do is look at that SageMaker catalog integration. So back in the project home screen, I can go over to assets. I can go over to data sources, and we can create a data source pointing at this Redshift environment. I'm going to select Redshift as the data type and select my connection pointing to my demo database, which was the target for our ZeroETL replication. I'm going to bring through all of the tables underneath our demo schema. And when we go and collect this metadata, I'm not going to immediately publish to the catalog. We're going to do some automated business name generation first. So this is that AI metadata generation previously discussed. We're going to use this to help us enrich the metadata around our data asset. We'll run this on demand and we're going to create. Once you've created and run your data source, essentially that goes out, connects to the Redshift environment, and then scrapes the table information underneath the schema we specified. We only have one table, and so it's our pipeline data. You can see that here. So again, right now, we've got some basic technical metadata, but we don't have anything beyond that. So let's generate some business descriptions. So this is using generative AI to look at the table schema, look at the information we have available to us, and try and suggest some business metadata. Once the metadata generation is complete, we can decide whether to reject, edit, or accept. I'm just going to accept it for now. And you'll see that we've had this nice sort of README type information generated for us, although of course you can specify your own README to go alongside this as well. Likewise, the table name has been updated with a suggestion to make it more business friendly, and also the schema and the columns have received new names and descriptions to go along them where before we had nothing. If we did have things like data quality as well, we could see those results here as well, likewise for lineage. But for now, I'm going to accept all of these recommendations so that we now have a more enriched asset that's going to be much more usable and searchable by the business. And we're going to publish that asset into the catalog. And then now, for example, if you were a different user coming along and you were looking for sort of pipeline information, you might search. And because of that rich metadata that we've associated with the table, we have suggestions recommended to us. And I can now get a good understanding of what this table is and decide whether to subscribe to it. So the next thing we might want to do then is look at using some of the generative BI capabilities. So before we can do that, we need to connect QuickSight to our Redshift warehouse. Now I launched this warehouse into a private subnet so that we can ensure that access is locked down and it's isolated. So the first thing we need to do then is make sure we can have access to that environment. So if I go over to QuickSight, what you can do here is go in and create VPC connections. So this is a connection that I've created that allows QuickSight to securely connect to a data warehouse environment without traversing the public internet. Once we have that in place, we can connect to that environment and pull in our data sources. I can configure our connection with the necessary authentication and to our target database, and then we can create the data source. Again, here I can select our repositories and pull in our pipeline data. Once that data is loaded, we can then start to visualize and use all the capabilities of Amazon QuickSight. To show you this in action, I'm going to use one of the sample data sets just because these are a bit richer than what I have. So I can come in here and you see we've got some visuals pre-created for us, but if we wanted to, this is where we could use the generative BI and we can start asking what do we want to visualize and have visualizations created for us. So I'm just asking a simple question here to generate a time series chart, and we can see that we have a visualization created for us. We can decide whether to update this or add to analysis. So this is one way in which the generative BI can help you in the building side of things and help you develop your visualizations and dashboards faster. But it can also help you on the consumption side as well. So to show you this, I've come over to this Demo Central environment where there's lots of different QuickSight demos that you can explore. I'm going to show you one here around Facebook campaign and ad analysis. You can see that we have this Ask Q search bar on the top. This is where we can come in as a consumer and again use natural language to ask questions of our data. So you can see here there are already previous questions that have been asked and been suggested to me. And when I submit this, Q behind the scenes looks across the data you have available to generate visuals and present you this analysis back. You'll have seen also that there are some that are marked with a green tick here. This is where admins or users with the relevant privileges have actually assessed the returned response here and marked this as valid. So somebody has asked a question already and verified that the result returned is accurate so that you can build trust in the generative experience. So as a bit of a recap, we submitted some data manually via our SQL client into our Aurora MySQL serverless that was acting as our operational database system. We configured the ZeroETL to send that data into Redshift. This gave us that data in real time in an analytical environment where we could then start building up our relevant analytics queries. We also turned on history mode as part of the ZeroETL integration to give us that additional metadata around which records are active and when they were created and updated. That can help us with ongoing change management and building slowly changing dimensions. We explored using the generative SQL capabilities in the Redshift query editor to start asking questions over our data, so it really accelerate that process of building your SQL transformations. And we also explored publishing that data asset via SageMaker Catalog and using some AI to help us with the metadata curation. We took a very quick look at the queue in data integration. And then we finally connected our serverless environment via secure connection to QuickSight. And we took a quick look at the different angles into the generative BI experience, whether that's as a producer, and we're using Gen AI to help us build visuals and dashboards, or as a consumer and we're coming in and then asking questions of our data.
So to show you a bit more around how you can create jobs with Glue, what I've done here is download some data from Company's House. And we've got some general cleaning up that we might want to do of this data. So what I'm going to do is load this data into S3, and then I'm going to use Amazon Q to generate a Glue job for me. So the first thing I've done is upload this data into an S3 bucket location. I've then used a Glue crawler to go and look at that location and infer the schema. So it's looked at that data set and it's figured out that these are the column names and these are the other data types. And you can see we've still got these columns with the dots in, and that's the thing we're going to focus on just for this demo to show some basic cleaning of the data. So the next thing I've done here is come across into the Glue console, and I'm just opening this job here that I've got as a bit of a placeholder for now, my company data transform. You'll see that I've selected the option to use the script editor rather than the drag and drop workflow. And now what I'm going to do is I'm going to ask the Amazon Q plugin to generate the job for me. So I open the Q pane, and now I can enter my prompt to Amazon Q. So you can see here I'm asking Amazon Q to generate a job that removes those dots from my column names in the company data Glue table that was part of my company data database. And then I've asked it to write the transform table into Parquet format and register the transform data in the catalog as a new table. So that's my prompt. I'm going to send that off to Amazon Q and get some generated code back. Once Q has generated its response, you'll see here that I now have some glue code that's been generated for me that I can copy and paste into my script editor. So straight away you can see the power here of enabling other users who may not be experts in Spark to get going quickly, or even just as a productivity boost to your existing analysts so that you don't have to start from a blank script. Once copied across, users are free to customize this code as they see fit. We see here that Glue has correctly referenced the company data table from the company data database. We see here that it is applying the naming updates to remove the dots from our column names. And then we see here we've got a bit of output, we've got a bit of configuration to apply to pick our output bucket. So I'm just going to use a bucket name for that. Once we've confirmed and we're happy with the code that's been generated, we can save the job and then select to run. Once the job has successfully finished running, you'll see now that in my target bucket and prefix location, I now have the data files written in Parquet format because I asked for that data conversion as part of my job into this SE location. You can see here in the Glue Data Catalog, within my company data database, I now have this new table defined, and the schema is now using naming that doesn't contain the dots in the column names, and my data is now stored as Parquet. So this is just an example to show you how you can quickly use Amazon Q to generate your glue jobs. We can even have data quality rules generated based on this information. So here I'm defining to use my same glue role. I'm not going to filter the data, and I'm going to ask for Glue to now recommend rules for me based on the schema of my data. You can see here the data quality rules that have been recommended off the back of this automated job. So these recommendations have been developed by looking at the schema of our table. We can now customize and update these rules as we see fit, add our own with the custom rule types here. And when you're happy, you can save the rule set. And then we can evaluate the rules against our data at rest so that we can start to build up a picture of the data quality of this data asset. We can also use these quality rules as part of our ETL jobs so that whilst we're ingesting and transforming data, if a certain threshold of rules are not passed, you can configure the job to either fail or proceed whilst emitting an alert, or even partition off the problematic data. Once our Glue data quality job has finished running, we will see the status and the overall quality score. So this is giving me the percentage of the rules that have passed. I can identify which rules have failed, and it gives me the specific values that have not met my criteria. So I can use this against my data at rest to build up a picture of my data quality. I can schedule these jobs to run so that I can keep refreshing that view of quality. And I can use the quality checks in my data pipelines to make sure that we only send trusted data forward into things like curated datasets supporting dashboards. We can also use Q to help us understand our logs. So I've come back to the script that we generated earlier, and let's imagine that we had made an error in our script. So for now, I'm going to remove this dynamic frame import, which we then later reference. So this is a fairly trivial example of an error that you might make, but I just want to demonstrate how Q can help you interpret these logs. So I'm now going to save the job, and I'm going to run. So we're going to expect this to fail, and we're going to see how Amazon Q helps us to interpret the logs and then find the cause of the failure and suggest a resolution. So we can see now that our job has failed, and I've come through to the job run details, and I'm going to ask Q to help me diagnose the issue. Like, as I mentioned, this is a fairly trivial example of a job failure. But if you've tried to debug Spark jobs before, we know that we get a lot of error and logging messages, and it can be quite hard to find the root cause of what's actually caused your job to fail, and also then to get an understanding of how to resolve the issue. So this is a really useful feature for helping you sift through all those logs and understand what's actually happened within your job. We see that once Q has finished its analysis, it's able to understand what the error is actually referring to and then offer up resolutions to the job. So principally, it's pointing out that we need to make sure that we are importing the right class. So we can use this information to now update our script and get the job working.
So hopefully that's given you a whistle-stop tour of a variety of different components related to ZeroETL and generative AI in your pipelines. If you're interested in looking more on some of the things we've spoken about, here are some relevant resources. And thanks very much for watching. I hope it was useful.